So let me start the recording. How are you guys doing? How's the exam treating you guys so far? Quite stressed. So this session is planned to be a question and answer session. So I'm here if you guys have any specific questions you want to ask. Anything you want me specifically to do? I apologize for being late. This day completely ran away with me. No, no, no. You don't need, like I said in class, you don't need to know the Einstein field equations. That's just part of the background. So there's not going to be any questions about it. It's just to show you where the work comes from and to provide background information about a work. So will there be a memo posted for the mock exam? So if you look at one of my lecture recordings, we went through it. But if you want now, we can go through the memo of the mock exam. Will that help? Will that help you guys? So will the exam be similar to the semester test and mock exam combined? Yes, that is correct. Only a little bit longer than the mock test and mock exam. So to give you guys about the exam, you will have 2 hours to complete the exam. The exam will be out of 76 marks. You will be given a formula sheet such as the semester test. You will be able to use your calculators. So the calculations you will do will be in the same as the semester test. So a hint that I can give you guys for calculations is, firstly, remember the calculations of absolute magnitude. So if I give you 2 stars, then you have to be able to calculate which one is brighter, which one is fainter, and with how much. We've done that in the semester test. So from that 76 marks, the breakdown will be multiple choice and longer questions. So 54 questions will be multiple choice, 1 mark per answer. So 54 multiple choice questions. And the rest will all be longer questions. Does that help? Yes. So can we go through formulas? Yes, we'll do it now. I'll upload it. So unfortunately, I'm not on campus tomorrow, but you are welcome to come and collect your semester test before the exam on Thursday. Let me quickly just find where I saved the mock test and mock exam. Okay, here is the mock exam. Okay, that's busy uploading. I can also give you guys the formula sheet. So the first thing is, let's go through the the formula sheet. So unfortunately, I cannot upload the semester test question paper to ClickUp. So for the formula sheet, it's quite easy, quite straightforward. So this question right here is for the magnitudes of stars. Quite easy, quite straightforward to use. So this right here is the logarithmic form right here as well. So this is just the ratio of luminosity with radius and temperature. So you are not basically going to use this one for this exam. This is Kepler's third law. So remember, when you are, say, for example, given Saturn, and it says Saturn orbits the Sun every 27 years, calculate its distance from the Sun, you use this formula. But remember, the MA and MB combines as one solar mass. So that equation becomes 1 equals to a to the power 3 over rho squared, and that is easy to calculate it. So another one you can use is that stands out is basically those few equations. So what are those two variables? That's something you should know for this in any case, but let me rather ask you before giving you guys the answer, what does the A cubed stand for? Distance from the Sun. Can anyone else second that? Not area. So one is distance from the Sun. The other is orbital period. But which one is which one? So yes. So for this, it is correct. Third law states orbital period squared and distance cubed. So rho is cubed, this is distance, and then A is the period. Easy, straightforward. You guys happy with that? Awesome. So quickly, let's go through the, where is that now? The mock exam memo. So when we look at this is something you should know from your moon assignment. The first quarter moon rises when? Yes, you guys are correct. Let's mark the answer. And that is, let's make this finer, is number A, at noon. Question number 2. This is familiar, right? Star A has an apparent visual magnitude of 13.4 and star B has an apparent magnitude of 15.4. 58.4. So star A is what then star B? Would you like, you guys want me to do this equation with you, or will you be able to solve it on your own? Okay, so easy, straightforward. We have FA over FB equals 2.51 to the power MB minus MA. So what do we plug in where? So when we do this, we say that equals 2.51 to the power. So star A has a magnitude of 13.4. Star B has a magnitude of 15.4. So that's 15.4 minus star A, 13.4. And if we plug that into our calculator, what do we get? 6.3. So, is it now 6.3 times brighter or fainter? Why brighter? Lower apparent magnitude is brighter, the higher the magnitude, the fainter is. You guys are exactly correct. So yes, it is 6.3 times brighter. So straightforward, right? So now, question 3. If light takes 8 minutes to reach Earth from the Sun and 1.3 hours to reach Saturn, what is the distance from Sun to Saturn? How would we do something like this? Would you guys like me to do this with you? So this is just basic arithmetic. So it's 8 minutes for Sun to Earth. And we know it's 1.3 hours from Sun to Saturn. So what is the first thing we need to do? So the first thing is, are we working in minutes or are we working in hours? What is the most convenient way? Yes, minutes. So 1.3 hours is how many minutes? Yes, you guys are correct. That's 78 minutes. So now it is quite easy to do. Because what is the distance from Earth to the Sun? 1 AU, that is correct. So we now know 1 AU equals 8 minutes, right? So now what is 78? Divide 8. Yes, 9.75 AU. And that's it. So when we look at our answer sheet, that's number C. Straightforward, right? So for the hint for the exam on Thursday, these two calculations are important. Are you understanding what I'm saying? Or do you catch the hint? Awesome. So question 4. What is the approximate age of a star cluster if the turn-off point lies for spectral type G stars? So we know G stars are some of the oldest stars in our galaxy. So 2 million years is way too short. 2 billion years is way too short. 100 billion years, our galaxy is not that old. The age of the cluster cannot be estimated. That's false. That's false. That's false. That's false. So 10 billion years is the correct answer. You understand how we got to that answer? Can we move on to can you explain please, sir? Okay. So what is the approximate age of a star cluster if the turn-off point lies with spectral type G stars? So we know G stars are red giants, which are cool, but G-type stars are also some of the oldest stars we can observe. So our own universe is 13.8 billion years old. So nothing can be older than 13.8 billion years. So we know G-type stars are very old stars. So 2 million years is way too short. 2 billion years is way too short. 100 billion years is impossible because the universe is only 13.8 billion years old. And then E, the age of the cluster cannot be estimated. Yes, it can be estimated. So it has to be 10 billion years old because they are very old stars. Awesome. Can we move on to the next question? Awesome. So the next question is straightforward. So which star with absolute magnitudes given below has the greatest luminosity? Any suggestions? Yes, that is correct. It is number D because it is the largest negative number. Does everyone understand how we got to that question? So now, question number 6. If a sunspot has a temperature of 4,500 Kelvin and the surrounding solar surface has a temperature, this is a typo, that should be not 4,500, that should be 5,800 degrees Kelvin. How many times bright is the surface compared to the sunspot? Any ideas? How would we do that question? Any idea, guys? So let's go to our formula sheet. And what does that answer give you? Yes, that is the correct way to do it. So, do you guys know which formula is the correct formula to use? So the correct formula to use over here is this formula. So we can now rearrange this formula because these two are basically given constants. So the only thing we have left is the temperature. So what we can do with this temperature, we can write this then as the temperature of 1. So we can say it's temperature of FB over the temperature of A to the power 4, it's temperature of FB over the temperature of A to the power 4. And a different way this energy equation comes from is the same as this equation over here. So it's L over solar equals R over solar radius to the power squared, and that equals to T over the solar temperature to the power 4. So now with this equation, we know we are working with one solar radius, so it's L. We know the radius of the sun is constant, and the radius of the sunspot compared to the sun are so insignificantly small that we can say this is 1 squared. And the only thing we are left over is T over solar temperature to the power 4. So now what we need to do is we just take these two values, we plug it into the equation, and we get our answer. And then when we do that, we get C. You guys happy with that? So another hint, if you catch my drift, remember this calculation for the exam. Do you guys catch my hint? Awesome. Question 7. The options below list the spectral type of 5 stars. So which one has the lowest surface temperature? So the lowest surface temperature is M5 because we know O stars are extremely bright, but extremely luminous, but also extremely warm. So we use again this OB, a fine guy or girl, kiss me. So here is M. So that means M-type star has the lowest surface temperature. You guys happy with this explanation? Awesome. Also, from your moon assignment, what would be the phase of the moon if it was observed at a vernal equinox on the 21st of March? So that will be B, the new moon. Guys happy with that? Can we move on? Okay, awesome. So question 9, again, is a calculation, same as the first one. So you guys are able to do this calculation now. So in this case, the answer here is what? What would you guys say? YC. You are correct. It is 16 times fainter. So yet, please take a look and see these two values as swapped around. So it's fainter, yes. Question number 10. What is or are the hot gases that are the moving extension of the sun's corona? Yes, you are correct. That is the solar wind. Question 11. What is the predicted end of a white dwarf? That is B, a black dwarf after a long time. And this was one of the longer questions in the semester test. And the majority of the class actually got this question wrong. So remember, the expected death of a white dwarf is a black dwarf after a very long time. Question number 12. Star cluster. So how does this occur? So remember, our own sun is an average type star. So when you have an average to a small type star, at the end of its lifetime, after it stopped fusing elements, so the average type star cannot fuse elements higher than carbon. So at the end of its life, it will blow off the outer layers of its atmosphere. And the only thing that will remain of that star is its naked core. And the core will still radiate energy. And the layers it is blown off is called a planetary nebula. So the naked core that remains and still radiating energy is called a white dwarf. But it's not fusing energy anymore. So for another couple of billion years, it will radiate energy into space. But after it has radiated all its energy, it will just be the naked core that remains. And that we call a black dwarf. Does that answer the question? Awesome. So question number 12. Star clusters are important to our study of stars because of what? The answer is C. They give us a method to test our theories and models of stellar evolution. Question 13. How does a gas cloud become hot by reactions? And that is quite an easy answer, and that is through compression by its own gravity. Can we move on to the next page? Okay, awesome. So, on the HR diagram, white dwarfs are found where? Yes, D is correct. They are found in the lower left corner below the main sequence. Question 15. Which star on the list below has the greatest diameter? So, this is number D because this letter here at the end tells us if it is a giant, supergiant, hypergiant. So M2 stars are cool stars, yes. Because they are M-type stars, they already have a large radius. But it once tells us it's a red supergiant, so therefore it has the greatest diameter. Does that answer the question? Or explains it? Awesome. So question 16, the human body temperature is 1 the largest and 4 the smallest. Yes, that is correct. Or not 4, 5 actually. Pleasure. So the human body temperature is about 310 Kelvin or 37 degrees Celsius. So what kind of radiation do we emit? Do we emit visible light, infrared, X-rays, UV, or none of the above? Yes, B is correct. We radiate in the infrared part of the spectrum. Number 17. Kepler's first law of planetary motion implies what? If you know Kepler's laws, it is D. The distance between a planet and the sun changes as the planet orbits the sun. Question 18. A meteor shower is produced when? So not C, a meteor shower is produced as Earth passes through the path of a comet. So remember, there are around about 2 meteor showers every year that we can observe from Earth, and that is when we pass through the tail of this comet. Then question 19. Why are massive main sequence stars not likely to have planets that contain life? And the reason for that is These massive stars are in the main sequence of far too short a time to allow for life to evolve. So the rule of thumb usually is the bigger the star is, the shorter it lives. The smaller the star is, the longer it lives. And then the last multiple choice question is, the moon has no magnetic field implies what? Yes, number D is correct. The moon's core contains little, if any, molten iron. Now for the longer questions. So how does a gas cloud become hot enough to ignite nuclear reactions? Then if you go through the work, and we spend a period on this, is compression by shockwave. So other stars will cause a shockwave, a compression shockwave that moves through the area that causes that molecular gas cloud to compress. If it starts compressing, then gravity does the rest. So before gravitational compression, you need compression by shockwave. Does that answer the question? Awesome. Then question 22. Give 3 properties of quasars that make them very strange objects. So the first property is quasars are very far away. The second property is they are very small. And the last property is they are superluminous. Did everybody catch that? Awesome. Question 23. What would you see if you were on the moon and facing Earth when people on Earth saw a total lunar eclipse? You would see a dark Earth with a red fringe around it. Then question 24. What advantage does a large diameter astronomical telescope have over a smaller one? So I asked this exact question in the semester test as well. And surprisingly, after we spend about a period on this as well, and this is in the mock semester test as well, the majority of the class got this question wrong as well. But the 2 marks for this question is, the one is you have better light gathering power. So you can think about it as a bucket collecting rainwater. The bigger the bucket, the more rain you collect. So a telescope, the larger the telescope, the more light you collect. So the first point is better light gathering power. Does that explain it? So the analogy is a bucket collecting rainwater. The bigger the bucket, the more rainwater you can collect. So with a telescope, the bigger the telescope, the better light gathering power you have, because the more light you can collect. And then secondly, the bigger the telescope, the better the resolution. And that's it. Then question number 25 is, a lot of people bugger this question up in a semester test as well. But from what you know about astronomical units and light years, how would you define a light minute? So remember, a light year is the distance that light travels in 1 year. So a lot of people confuses light years with time. Light years is not time. Light years is a measure of distance. It's a distance light travels in 1 year. So how would you define a light minute? It's a distance that light travels in 1 minute. So in the semester test, a lot of people said it's a distance the light travels from Earth to the Sun, which is incorrect because the distance from Earth to the Sun is 8 light minutes. So yes, the distance that light travels in 1 minute. And that is the question. So since there's only a few of you online, would you like to give me the second reason why a large diameter telescope is better? You have a better resolution. Thank you. A pleasure. So, would you guys like me to give you a few more hints and tips for the exam? Okay. So let me quickly see how I can help you with this is. So another question is, are you guys familiar with the vernal equinox, spring equinox? What is now the 20th of June? 20th of June, when we write the exam, is the longest night and shortest day. Winter solstice, yes, that's correct. So for example, if I ask you the question, on the vernal equinox, the sun is where, and I give you a list, will you be able to determine where it is? So if I say on the vernal equinox, the sun is, then the correct answer would be on the celestial equator and moving north with respect to the equator. Then another hint is if I ask you, when does the first quarter moon rise? Will you be able to answer it? Okay, so let me see what else I can. So another one is, so what keeps the nuclear reactions in a star's core under control? And the answer there is pressure depends on temperature. Easy and straightforward. So let's see, what else can I ask you? So another hint is, what is the difference between a meteor, a meteorite, and a meteoroid? Another question is, and this is something I always ask in the exam, is what are the 4 stages in the development of a terrestrial planet? So then you have to list the stage and describe it. So those 4 stages are flooding, cratering, differentiation, slow surface erosion. So that's something you should know as well. So what are the 4 stages of a terrestrial, what is the 4 stages in development of a terrestrial planet? So will this lecture recording be made available? Yes, it will be. So I'm coming to that as well. So let's see. So one thing is, what does the Chandrasekhar limit tell you? Also another hint, know Kepler's 3 laws. Not just list them, but I can, for example, tell you explicitly what is, for example, Kepler's second law, and you guys have to know what that is. Let's see what else I can give you as a hint. So another question is that I usually like to ask is, how did Earth avoid the greenhouse effect that made Venus so hot? So how did Earth avoid the greenhouse effect? That's 2 marks. Another question I usually like to ask is, how did the dinosaurs become extinct? And through the years, I found some really, really, really terrible answers. And the dinosaurs did not die of the impact itself or volcanic eruptions. So the first thing that the asteroid impact did is it knocked up a lot of dust in the atmosphere. The second thing is because all the dust in the atmosphere, it caused a cosmic winter. With the cosmic winter, it means plants cannot go through the photosynthesis process. So that means not enough food for the herbivores. If the herbivores died, not enough food for the carnivores. And that led to a global lack of food. And that's it. Dust in the atmosphere, cosmic winter, and global lack of food. Another question I also usually like to ask is what are some outstanding issues we still have in astronomy? So some of those outstanding issues is, what is dark matter? What is dark energy? What is the mass of a neutrino? So something that hasn't been explained in astronomy yet, and we've talked about a few of these things throughout the semester. Then, another question I also usually ask is what evidence do we have that the universe began with the Big Bang? And what evidence do we have that the universe is expanding? So that is also straightforward. And then lastly, a question that I always ask in the exam is, what is the Drake equation? And then with that is you have to list the Drake equation and explain every variable of the Drake equation. And that's all the hints I can give you guys. It's a pleasure. So how many marks for the Drake equation? So a question for the Drake equation will usually be in a ballpark of around about 10 marks. So unfortunately, I don't have any more practice questions. But if you just go through the work and just understand it, don't memorize anything, just understand it, and you'll be able to puzzle it out. So can we go through the Drake equation? Yes, we can go through the Drake equation. Let me just open it up on my side. Let me just find it so I can show it to you. Okay, so the Drake equation is in the last chapter. So let me get the whiteboard out. So the Drake equation, if you give the Drake equation, it is NC equals N asterisk times FP times NHZ times FL times Fi times Fs. So what that means is NC, that is the number of possible intelligent life or intelligent civilizations in a galaxy. So to get to that upper or lower estimate is we have N asterisk, and that is the number of stars in that galaxy, or for this theory example, in a typical galaxy. If P is the fraction of those stars that has planets. NHZ is the number of those planets that are in the habitable zone of their host star. If L is the fraction of those planets in the habitable zones where life can begin. If I, that's the fraction of planets where intelligence starts to evolve. And then Fs is the fraction of that star's existence during which technological civilization survives. So basically the lifespan of that civilization. And then if you plug in optimistic values, you'll get how many possible other civilizations there are. And that is the sweet and short of the Drake equation. It's easy, right? Awesome. So do you guys have any other questions? So yes, you should be able to write it down and explain every variable. And besides explaining every variable, explain what the Drake equation is used for. And so what is the difference between dark matter and antimatter? So those are completely different things. So dark matter is, we realize the majority of matter in the universe is dark matter. And dark matter does not interact with normal matter. Antimatter is not dark matter. Antimatter is the opposite of normal matter. So the antimatter particle, for example, of an electron is a positron. And if you add an electron and a positron, they cancel each other out, so you have nothing left. So if you add normal matter and antimatter, they cancel each other out. But dark matter is completely different and something we still do not understand. So yes, for like 10 marks. So in something like that, each variable will be a mark. And so each variable and the explanation of a variable is a mark, and then what Drake equation is and used for will be another mark. So are there any other equations we should know that are not given on the formula sheet? No, the Drake equation is the only one. For the planets, how extensive must our knowledge about them be? So not extensive, just the overview. So for example, if I ask you, why is Uranus's rotation peculiar? Then you should be able to answer it. For the terrestrial planets, what are the 4 developmental stages, for example? What is something else I can possibly ask for the planets? Let me see if I can think of something. So if I ask you, for example, let's take Jupiter, for example. If I ask you, give you an example, so let's go through, I'm making this up now as we go along. So Jupiter does not have, and I give you a list. And in a list, there can be a hot interior, convection occurring in the atmosphere, crustal plates on its surface, the dynamo effect, or any rings. Then you should automatically know Jupiter does not have crustal plates. So it's just straightforward planets, straightforward on questions. So no, 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 not what was the first rover or anything. That's something you can read up about. So no information like that. That's just background information. But what rather is important is if I ask you, for example, what is the biggest mountain in the solar system? Then you should know that's Mount Olympus Mons on Mars. And for example, thinking about what is Jupiter's 4 biggest moons, then you should be able to list them as well. So just basic overview details of every planet, not detailed questions, just overview questions. Does that answer your questions? Awesome. So that is it. So tomorrow there will be another recap session. So if you have any more questions, tomorrow evening from 5 to 6, I will answer them to the best of my ability. Otherwise, have a wonderful evening. If you are writing any other exams in the week, good luck with preparation for that. And I'll see you all tomorrow. Have a great evening.